For question 6, a right circular cone of height h just fit inside a sphere of radius r. So for the first task, we're going to show the volume of the cone is 1 over 3 pi h squared times 2r minus h. So we have to identify our variable here, where h is referring to the height of the cone and r is referring to the radius of the sphere. So as we can see here, our shape, it is a cone and then inside a sphere. So the sphere here, we have a radius r, and our cone here, we have our height of the cone, which is h. So as we can see from the question A, they ask us to find the volume of the cone. So the volume of the cone is supposed to be 1 over 3 pi r square h. So r will be referring the radius of the cone. So the radius of the cone, we label it as rc. So h, the variable h, still maintained as this because h is the height of our cone. Our variable here we can use here. So we have to express out how to find out our radius of the cone that will related to our radius of the sphere. So we can see in our diagram here, as this is the center of the sphere, so as I drag it to the vertex of the cones here, it will be our radius. So when I draw it to the bottom here, it also our radius. So from here we can obtain a triangle. So our triangle will be forming, where the base of this triangle is our radius from the cone. Radius from the cone. The hypotenuse here is our radius from our sphere, and of course the height of this triangle will be our radius of the cone minus this. So to be easier, it will be height our height our whole height minus our r. So to be easier, we want to obtain the height of this triangle. It will be equal to h minus r. So from here we can get to our relationship of our radius of the cone with the radius of the sphere. So from this triangle, we can build out a Pythagoras theorem, where r squared will be equals to h minus r squared plus rc squared. So what we want to find here is rc squared. So rc squared will be equal to r squared minus h minus r squared. So we try to simplify here. We expand this. It will give us h squared minus 2hr, then plus r squared. So as we simplify again, it will be r squared minus h squared plus 2hr minus r squared. So now our r squared will be simplified. And then we can factorize out our h here. We can get negative h plus 2r, so which is equals to 2r minus h. Then we substitute back into our formula where our radius of the cone is expressed into term of h and r given. So volume of the cone 1 over 3 pi rc squared is equals to h times 2r minus h, then times h. So it will equal to 1 over 3 pi h squared times 2r minus h. So this is the formula we need to show it. Then after we getting this volume of the cone, we have to proceed to our second question. We have to maximize this volume of the cone. So we have to maximize this equation. And then it show that it is 8 over 27 times volume of the sphere. So as we have our volume of the cone, V equals to 1 over 3 pi h squared 2r minus h. Notice that in this equation, V is in terms of h and r. But in order to adjust our cone here, we want to maximize our volume of the cone here. So only the h will be the variable. The r referring here is a radius of the sphere. So the sphere, they didn't do any changes. So the sphere is constant. So we want to modify our cone become maximum. The variable changing will be h and rz. So RC already substitute in terms of H and R. So our R is referring to our sphere. So our R is our constant. So from here, so our variable is our H. Our constant is our R because R is radius from our sphere. So we're going to differentiate with respect to H. So for this formula, we expand it first so that we can differentiate it individual one by one. So after we expand, we get 2 over 3 r pi h squared minus 1 over 3 pi h cubed. So we differentiate our v with respect to variable height because when we changing our volume of the cone, the h also will be changing. So the r here, we assume it is a constant. So power move to the front, it will become 4 over 3r pi power minus 1h. So same thing, power move to the front, so it will cancel the 1 over 3. So power minus 1, it becomes 2. So we need to maximize this volume of the cone. So in order to maximize, we will let this first derivative equals to 0. So 4 over 3 r pi h minus pi h squared will be equal to 0. We will find out our critical value. We will find out our h value here. So as we can see here, our h can be simplified, can factorize out. And we can obtain our h is 0. So this is 4 over 3 r pi equals to pi h. So pi can be simplified. So another critical value of h here is 4 over 3r. So both of them is our critical value when we changing our volume of the cone to maximize it. So we have to verify these two critical value to show that it is a maximum case. So to verify this, we're going to use second derivative test. So from this first derivative test, we're going to differentiate it again with respect to h. So 4 over 3 pi 4 over 3 pi, and then power move to the front, 2 pi, power minus 1. So we will substitute our h equals to 0. When our h equals to 0, we get 4 over 3 pi. It is positive. So when it's positive, second derivative test is talking about concavity. Positive will be concave outwards, so this is a minimum case. So another critical value when h equals to 4 over 3r, substitute in second derivative. So here we have 4 over 3 pi r minus 8 over 3 pi r. We will get negative 4 over 3 pi r. So negative less than 0. Concavity downward, maximum case. So we already maximize our critical value. We already verified our critical value, where when we want to find our maximum volume of the cone, the h will be equals to 4 over 3 r. So h maximum equals to 4 over 3 r. Then we're going to generate our volume of the cone, which is maximum. We substitute this h back to our formula of the volume. So which is 1 over 3 pi, where h is 4 over 3 r square, and then this is 2r minus h is 4 over 3 r. So simplify this equation. Simplify this expression here, where 4 over 3 square times 3, it will give us 16 over 27. So this is pi r square. Inside here, 2 minus 4 over 3, it will give us 2 over 3. 2 minus 4 over 3 will give us 2 over 3 r. So simplify, we will get, this is 32 over 81 pi r cubed. So this is the maximum volume of the cone. So after we obtain this maximum volume of the cone, we will try to prove it is 8 over 27 times of the volume of the sphere. So we have to do the ratio. So the following step, we're going to find out the volume of sphere. So they just want the volume of sphere, no need maximum and minimum, just normal volume, because our sphere is constant. So volume of the sphere formula is 4 over 3 pi r cubed. So when we compare it, when we do our ratio, volume of the cone maximum ratio to the volume of the sphere is equals to 32 over 81 pi r cubed ratio to 4 over 3 pi r cubed. So we can notice that this pi r cubed can be simplified. And then we try to press our calculator. What's the result of 32 over 81 divided by 4 over 3? So it will give us 8 over 27. So we move back. Therefore, we managed to prove that volume of the cone maximum is 8 over 27 volume of the sphere. So this is how we prove our sentence. So we can rewrite it in our sentence here, where maximum volume of the cone is equals to 8 over 27 times volume of the sphere.